Hey, this is a video for 7.1, Introduction to Air Pollution. So go ahead and check out the overview and set up your guided notes. So air pollution is the introduction of substances into the atmosphere at concentrations high enough to harm organisms, buildings, or ecosystems. Now we have different types of air pollutants. We have primary pollutants, which are pollutants that have been emitted directly from a natural or anthropogenic source. Remember that an anthropogenic source just means that it's caused by humans. Some examples are, and I'll describe these in more detail, but some examples are NOx, SO2, carbon monoxide, carbon dioxide, lead, particulate matter, VOCs, and mercury. Now, a secondary air pollutant, they have undergone some form of transformation in the presence of sunlight, water, oxygen, etc. Now, these are going to occur more in daytime and in wet conditions because you have sun, which provides the energy, and water, which will provide something for a chemical reaction. Some examples of these are ozone, SO3, sulfuric acid, we have peroxide, we have nitric acid, and PANs. And I'll describe these again in much more detail. So in 1970, the U.S. Congress passed the Clean Air Act, and that authorized the Environmental Protection Agency, or the EPA, to set air quality standards. And one of the things that the EPA did during the Clean Air Act was established 6 criteria air pollutants. And they have this wonderful acronym, but they were identified through the Clean Air Act of 1970 as a threat to human and environmental health with this acronym, nose clip. Just think, air pollutants, nose clip, cover your nose. So that's NOx, we have O3, SO2, carbon monoxide, lead, and particulate matter. And I will go into each one in a little bit more detail. So they can come from either natural sources, they can come from agriculture, which is anthropogenic, they can come from transportation and industry, or they can come from urbanization. And we will talk about all of these in far more detail. Starting with nitrogen oxides. Now you can use NOx to describe either NO or NO2, and it doesn't really matter because they are both being formed in the same process. So you can use the term NOx as a blanket statement. But you can have natural sources, and that could be from the combustion of organic materials, like after a forest fire. They can come from abiotic fixation of nitrogen via lightning, and also from bacteria action in the soil through the nitrogen cycle. Now, this is natural. Anthropogenic sources include industrial sources, predominantly generation of electricity using fossil fuels as the energy source, and also transportation. Now, some impacts. Predominantly, we're going to have acid precipitation. That will be an impact environmentally, and a anthropogenic or a human impact would be respiratory irritant, lung irritation, different respiratory diseases. Now, tropospheric ozone. Ozone, first of all, it is a secondary pollutant that is formed by sunlight and water reacting with VOCs, NOx, and oxygen. And I will definitely go over this. In fact, the next video topic is just related to tropospheric ozone. Normally, it is found in the stratosphere, so stratospheric ozone is a good thing, but when it is found in the troposphere, it is a bad thing. It is a respiratory irritant. It can cause asthma, bronchitis, and emphysema. A lot of urban areas have people with higher rates of asthma, and if you did a survey of, students from Brooklyn and students from, suburban areas, you're going to find higher rates of asthma in students that live in urban areas like those in Brooklyn. It also can contribute to plant damage, and that could impact our agricultural crops. But along the same lines, it will just damage non-agricultural crops as well. So the plant damage could actually be human or environmental impact. Now, the reason it damages the plants is the ozone will oxidize the tissue in the plants' tissues, and predominantly it will be impacting the leaves. So when the leaves are damaged, they cannot perform photosynthesis. It is also a greenhouse gas, so additional infrared radiation will be absorbed, and that energy that is absorbed will be re-radiated back to the Earth's surface. Now, sulfur dioxide, or SO2, is another one of the criteria air pollutants. Naturally, it can come from forest fires, from any sort of organic material that is combusted. It also comes from volcanic eruptions, releasing sulfur far into the atmosphere. Now, anthropogenic, it is like nitrogen oxides. It can come from industrial generation of electricity through fossil fuel combustion, and it can also come from transportation, which is combustion of fossil fuels through the internal combustion engine. Now, it can lead to tissue damage in a plant, and it can also lead to respiratory irritation in humans. Now, lead can be found naturally in rocks. Anthropogenically, it was once used as a gasoline additive. It is also it was an additive in paints, and it was also used to make pipes. Now, lead pipes are being phased out. There still are many municipalities that do have lead pipes, but it's a problem because it can contribute to neurological damage in humans and in other organisms. So it definitely will impact the development of neurological tissue, leading to brain damage. Now, carbon monoxide is formed from the incomplete combustion of organic matter. So anytime you take carbon and you burn it in the presence of oxygen, you're getting carbon dioxide. But it's not always going to burn perfectly. So sometimes you're going to get incomplete combustion, and that will lead to carbon monoxide. I will let you look at these wonderfully hysterical GIFs that I have, or memes that I have made. This was part of our meme project a few years ago. But they can come from human causes, or anthropogenic sources are from vehicle exhaust. It can also come from home cooking and home heating. And environmental causes are from volcanic eruptions and forest fires. It can lead to asphyxiation because carbon monoxide will bind to the hemoglobin in our red blood cells, and hemoglobin normally binds to oxygen and carries the oxygen to our cells. If we don't get the if we don't get the oxygen and we're taking carbon monoxide around instead, it will lead to our cells not having enough oxygen. So it's basically hypoxia from the inside. Now, there are some danger zones in our homes, and these are areas around the home where carbon monoxide can be generated. So anytime you are doing some of those activities, like burning wood or any organic material, can come through the chimney, in the fireplace, cooking appliances, heating equipment, generators, and car exhaust, and grills. The last three are very, very particular or very important to pay attention to. If you ever run out of electricity, you should never run a gas generator in your home because carbon monoxide will be released. You should never run your car in a garage because you can asphyxiate yourself from carbon monoxide if the garage is not well ventilated. And also, you should never cook anything on a grill unless it's an electrical grill, but you should never cook anything on a grill indoors because that carbon monoxide can come into the house or can pass around the house. And this is one of the reasons why we also have carbon monoxide detectors. Because carbon monoxide is odorless, you cannot tell that it is around. You basically will pass out before you die. Now, particulate matter is another one. Particulate matter is very small. Basically, it's soot or smoke, and it's much smaller than a human hair. like I would know. Human hairs are typically 50 microns. That is micrometer. That is a symbol, the Greek symbol. It's the mu symbol and then an M for meter. So 50 micrometers or 50 microns is a human hair diameter. And the PM10 refers to the distance or the diameter. It is 10 micrometers. And the PM2.5 is 2.5 micrometers. Now the PM2.5 is far more deadly and far more dangerous than the PM10 because it can embed itself deeper into our lung tissues. So it is caused by the combustion of fossil fuels and biomass. Anytime we're burning anything, the smoke, the soot, that is particulate matter. It can also come from road dust and crushing rocks like during construction. Naturally, it can come from volcanic eruptions, it can come from forest fires or dust storms. And the impacts are really deadly. It can lead to respiratory illnesses, respiratory irritant, the PM2.5 and the PM10. The PM2.5 is a major cause of lung cancer. Because it is so small, it can embed itself into the lung tissues. It will also block sunlight, and it can minimize or impact photosynthesis. If you're not getting sunlight, you're not going to get photosynthesis. Now, other pollutants that are not criteria air pollutants. One of them is a volatile organic compound. And these are easily vaporized from solids or liquids, and they often have a chemical smell. So some examples are paint, paint strippers, other solvents, aerosol sprays, cleansers, any disinfectants, moth repellents or air fresheners. You have fuels, automotive products, pesticides, and a natural source is from evergreen trees or other conifers. That like pine tree type smell is from volatile organic compounds. The Great Smoky Mountains, the reason why it is smoky is because there is this volatile organic compounds that are floating in the atmosphere. Another example of a pollutant would be mercury. And mercury is released through the combustion of coal and petroleum. Mercury is released into the atmosphere where it will undergo a reaction, get mixed in with the precipitation, which will eventually fall back to Earth to be picked up with the water. It'll be picked up by aquatic organisms or by plants. And when it contacts with water, it will convert to methylmercury, which is very toxic. And it can build up or bioaccumulate in the tissues of larger fish. So for starters, it impacts the nervous system. It can also impact a child's mental development. So if you consume a lot of mercury when you're pregnant, you could impact the neurological development of your unborn fetus. Now, it can bioaccumulate in large predatory fish. Fish like tuna have high levels of mercury in them. Another pollutant, carbon dioxide, wasn't established as a criteria air pollutant during the Clean Air Act of 1970, but it is a major air pollutant. And we've been talking about carbon dioxide this entire year. Now we'll talk again about how the carbon cycle is impacting. These units that I'm giving you are in 10 to the 15th grams of carbon. So in the atmosphere, for example, we have 750 times 10 to the 15th grams of carbon. That is a carbon reservoir. Another carbon reservoir is in organic material like plants. We have 4,000, this is more of a carbon sink, 4,000 times 10 to the 15th grams of carbon is stored in fossil fuels. 1,500 is found in the soil. 38,000 is found in the ocean. It seems like a lot, but we have over 100 million times 10 to the 15th grams of carbon that are found in rocks on Earth. Now, 6 times 10 to the 15th grams of carbon is released in the atmosphere through the combustion of fossil fuels through anthropogenic sources. 60 times 10 to the 15th grams of carbon is coming from respiration in the soil. 60 times 10 to the 15th grams is coming from respiration of plants and animals. 0.1 times 10 to the 15th grams of carbon is coming from volcanic activity. Even though we think that volcanic activity is a major source, it is actually not. We have 0.9% is coming from decomposition of materials and from deforestation. We have 90 times 10 to the 15th grams of carbon is coming from the surface ocean. And then we have 92 times 10 to the 15th grams of carbon is actually entering the ocean from the atmosphere. So here we're having a net gain in oceanic carbon. We're also having 120 times 10 to the 15th grams of carbon being taken in from the atmosphere through photosynthesis. And 60 times 10 to the 15th grams of carbon are going into the soil through decomposition and the act of decomposers. Now, this is again that famous Keeling curve that is taken from Mauna Loa in Hawaii, and the reason it's taken there is because it is pretty secluded. But over the last 60 years, we've been monitoring the carbon dioxide concentration atmospherically, and we've seen that it has steadily increased. And there is this fluctuation up and down between winter and summer. In the summer, more carbon dioxide will be taken out. In winter, more carbon dioxide will be added to the atmosphere. There is a lot of information. So I would like you to respond to this check for understanding. And now, for FRQ practice, I would like you to describe a human and environmental impact from atmospheric mercury. I hope that this video is informative. I thank you for your attention. I'll see you soon.